back to DECIDEthought. I'm your host today, John Heemeyer. We here at DECIDEthought are a contentious bunch, especially when it comes to the lack of details that we as civilians receive about many scientific theories, or the lack of details as to why certain facts are, well, facts. Today, we are going to be looking at one of these scientific concepts that we just don't have enough information on. So, after our research failed to answer our questions, we decided to talk about them and posit some alternative theories. Today's contentious subject is cosmic microwave background radiation. Simply put, the cosmic microwave background radiation, or CMBR, is understood to be radiation from the start of the universe that has been stretched to its current microwave length. Okay, that's it. What it is and what caused it explained. Talk about a short episode, right? Yeah, not quite. We here at Decide have a few issues with this explanation, so we decided to take a closer look at it. Our first issue with CMBR was the concept that it was uniform in all directions. This confused us, because if we look at the CMBR maps, we can clearly see hot areas and cold areas. Definitely not uniform. So we decided to look at the actual change in temperature from these areas. The difference in temperature between the hot and cold areas is approximately 0.0000352 degrees Fahrenheit. That's less than 1% of 1% of 1 degree. Not much difference at all. Okay, so we can understand how this can be considered mostly uniform in terms of temperature. The next issue we have is the wavelength of this CMBR, most specifically concerning redshift and blue shift. A quick overview of red and blue shifting is that when items are moving fast enough away from us, the light that is emitted turns more red in the visual spectrum. This is redshift. Objects that are moving slower away from us or are moving towards us will appear to be bluer in the visual spectrum, thus blue shift. Both of these are based off the frequency of the wavelength of light. It is noted that it is easiest to record the CMBR between a wavelength of 70 gigahertz, that is 70 times 10 to the 9th power, and 217 gigahertz, 217 times 10 to the 9th power. Well, that certainly is more than the difference between the wavelengths of red and blue light. Red light being 4.3 times 10 to the 14th power, and blue light being 7.5 times 10 to the 14th power. So, at first glance, it would appear that CMBR follows this same principle. Just one problem. Nowhere have we found anything that declares this frequency is direction-based, which it would be if it did follow this principle. Add this to the CMBR temperature map, and we have to wonder, are the hot and cold areas of the CMBR map, can they be defined by this wavelength? I.e., are the hot areas the 217 gigahertz readings and the cold areas the 70 gigahertz readings? We could find nothing stating one way or another on this. This lack of information makes it difficult to believe what is being said. Science isn't about blindly following a set of theories and beliefs. Without this information, we are forced to question the validity of what CMBR is, or is declared to be. Which brings us to our final issue. The claim that CMBR is relic radiation from when the universe was young. Certainly an understandable viewpoint and very logical. Until recently, we had decided didn't consider there might be alternate explanations. But we recently watched a video on 10 questions in astrophysics which cannot be answered. One of those questions was, where is all the antimatter? And we began to wonder a few things. First, does antimatter interact with dark matter? According to the video, antimatter and matter should have been created in equal amounts. But is dark matter a part of the matter portion, or was antimatter, matter, and dark matter created? Well, we know approximately how much matter and dark matter is in our universe. So if there's an equal amount of antimatter to just the matter or to both matter and dark matter, the question of where is all the antimatter is quite valid. Well, we came up with two possible explanations to where all the antimatter is, one of which deals with what the CMBR is. We'll do that one second. So, our first possibility to where is all the antimatter comes from black holes. Well, kinda. There are theories out there which posit the existence of something that would be the opposite of a black hole, commonly termed a white hole. In simplest terms, a white hole expels matter and potentially dark matter, dark energy, and even antimatter into the universe, whereas a black hole pulls all that into itself. Now, if one or more white holes exist in our universe, we'll get into why we haven't seen one in a later video. And these white holes, if they were created from the Big Bang, then maybe they simply haven't reached the point of expelling out the antimatter. Basically, for this purely hypothetical option to even be possible, a white hole must exist, and must be from the time of the Big Bang. Since the white hole expels matter and dark matter and some dark energy, this is what happened to allow the formation of the universe. Now, the white hole has expelled most of its matter and presumably dark matter. So it is currently pumping out a lot of dark energy in place of the matter and dark matter it used to expel. As dark energy is one of the explanations for our universe expanding at a faster rate, this seems to fit. When the white hole finishes expelling the dark energy, all that will be left within is the antimatter, which will be pumped out at the end of the white hole's life cycle, or more appropriately, at the end of our universe's life cycle. Thus, all the antimatter from the Big Bang could exist, it's just all in the white holes waiting to be expelled. Okay, so while a white hole is theoretically possible, there is no strict evidence of one existing. So we have to look at another option for where all the antimatter is. Now, I want you to think. What if we already know where all the antimatter is, and we're just not viewing it as antimatter? This second explanation looks at just that. We know from testing experiments that matter-antimatter collisions produce gamma radiation. What we don't know is how antimatter and dark matter interact. So, what if antimatter-dark matter collisions produce microwave radiation? Or more specifically, the CMBR, which we are picking up. If this is true, then that means all the antimatter created by the Big Bang is protecting our universe like a shell or the skin of a balloon. And as our universe continues to expand, that skin is going to naturally stretch and get thinner. This nearly uniform thinning effect, similar to a balloon skin when it expands, could explain the hot and cold areas in the CMBR maps. And if the CMBR is a recording of the emissions of an antimatter skin, then that also means that these hot and cold areas could be explained by recent impacts against the wall from the other side. Or it could be explained by dark matter impacting and bouncing off. Unfortunately, those of us that decide are mere civilians. We simply do not have the funding or equipment necessary to run the tests needed to prove or disprove either of these hypotheses. To that point, if you wish to donate to our research, you may do so via our website at DECIDEthought.com by clicking the donate option. The donation link will also be provided in our description below. Don't forget to like, subscribe, and share. The more views we get, the more donations we can receive, and the more research we can do ourselves, rather than simply working off other people's research. All donations will go directly to purchase, upkeep, and usage of equipment needed for research projects. In contrast, income from video views goes first to paying the crew, such as myself, and utilities. Then it goes towards research funds. So, whether you choose to believe that a white hole is still holding antimatter, waiting to expel it, or that the CMBR is a sign of an antimatter skin protecting our universe, or any other option, that is for you to decide.